The bearing of x from y is 65 degrees and the distance is 57 meters. The bearing of z from y is 145 degrees and the distance between x and z is 84 meters. Calculate the bearing of z from x. So from the question, the bearing of x from y, that means they're going to our starting point now will be y. So you do the small cardinal point here. So this is north. So this is your y to x. This is your x. So this is 65 degrees. And this is x. And also, according to the question, the bearing of x from y is 145 degrees. That means from here, you turn here is when you stop here is 90, 145 degrees to here. That means you turn 145 degrees from here. Yes, this is the something. So don't write it here, write it here 145 because we don't want to congest this place. This is your z, and the distance from x to z is 84 meters. That means from here, you now join it. So this is 84 meters. And this here is 57 meters. And we're now asked to find the bearing of y. Sorry, we're now asked to calculate the bearing of z from x. That means the angle from here up to this place. That's what we are looking for. Let me make it clear. Here to here. That's the bearing. So now we'll now do our homework here. We'll now see. That means this one here, the angle here. Let's call this place theta. And now let's see. From here to here is 90. So since it stops here, then this place will now be 25 degrees. And from here to here is 145. And 145 degrees we stopped here. So that's mean from here to here is 180. So here will be 35. So from here to here is 90. So if we move 35 from 90 to this place will now be 55 degrees. So the angle from here to here will now be 80 degrees. That to do it. So try and know all these techniques. So the angle here and here are the same because they are alternate angle. Therefore, this angle here will be 35. So to get the bearing, we get this small angle here. That means we are going to calculate the angle of here from here to here. So you now remove 35 from it. So the remaining one now will be theta. And this place will now also be theta. So you now add from here to here is 180. So you now add 180 to you now add theta to 180 and to give you the angle here. How to do it now? This one can be calculated by using sine rule. You say this over sine this equals to this over sine this. Now let's try it now. So 57 meters over sine z will be equals to 84 meters over sin 80. Sin z will now be equals to 57 times sin 80 all over 84. So sin z will be equals to 57 times 0.9848 over 84. So sin z will be equals to, so you now multiply and divide. If your answer is correct, you get 0.66, 0.866, 0.6648, 0.6648. So remember, we are looking for z, not sin z. So to get z here, it will become z now will be sine inverse of 0.8, 0.6, 0.6648. So z now will be equals to, now use calculator, press second function or shift, then press sign. This inverse will pop up. So you now input this and your answer will be approximately 42 degrees. That means from here to here is 42 degrees. So to get theta, you have to remove 35 from 42. So theta now will be equals to 42 minus 35 degrees. And the answer will be 7. So theta is 7. So the bearing from z, from the bearing of x from z will be 180 plus 7, which will give you 187 degrees. That is the